Let's go ahead and start on this bell work right here. So we're going to take this equation, and just like we saw last time, we're going to take it and change it into slope-intercept form. So only two principles of equality are needed to do this. First, to zero out that x, and to do that, I think I've said this before, if you like to see that as 1x, then keep it there with 1, but if you want to make it a phantom 1, that's fine. I like to see it because it's the coefficient of x, and we're going to need it for the slope. So the principle of equality there, if I do it to one side, I got to do the other side, and that brings down my equal sign right there. Okay, so 1x minus 1x is 0. Then I'll drop my 2y, but now it equals, and just like we saw last time, I'm going to switch up the order, negative 1x and then minus 4. And then the last thing I'm going to do here is divide all the terms by 2. Okay, so that gives us a coefficient of y that's a phantom 1, and this will change it into slope-intercept form. With the coefficient of x here, we can see is negative 1/2. The y-intercept, negative 4 divided by 2 there is going to be minus or negative 2. So on the graph, the y-intercept is going to show as not just negative 2, but 0, negative 2. And you could put that point on the graph if you'd like first, but I'm going to point out the slope here first, which is the coefficient of x, that's the negative 1/2. And again, just like we saw last time, I like to see the numerator take the negative. This allows me to make the run always positive, which means that my line will always go to the right. So I'm going to go down 1 because of the negative. That's my rise, and then the run will be to the right 2. Well, down 1 to the right 2 from where? That's where we need that y-intercept at 0, negative 2 right here. And then from there, down 1 to the right 2, boom, there's the next point, and then I'll just keep that pattern going. And yeah, I can copy that stair-step pattern to the left as well. Now I have the line that's created from the equation. And just like we talked about before, this indicates that each of these red ordered pairs and the y-intercept, if you were to put these ordered pairs, even like this one right here, negative 2, negative 1, if you put that into the original equation, it will give you a true statement. So we're going to be using this method today to graph lines, but today, instead of just graphing one line on a graph, you're going to have to put two lines on a graph. So there's our objective. I know a solution to a system of equations is the point of intersection between the two lines. Take 15 seconds and copy that down, please. A little bit of background here on this vocabulary stuff. A system of equations is just two or more equations at the same time. Just for us, we're not really looking at more equations, just two at a time. And that's nice because it's a lot easier to work out. But those equations should only have two variables, x's and y's. And then the point of intersection between the two, that's the actual solution to the system. That means we're just looking for an ordered pair for our solution, okay? And that means that for the assignment, you're going to have to enter these in as ordered pairs. So solving a system by graphing, and there are other ways to solve, but we're only focused on doing this by graphing. And so what you're going to have to do is take the two equations that are given and then put those two equations on the graph and then just see where they intersect, okay? So for example, if I go in here and maybe I draw some kind of line like, I don't know, this one right here. And maybe I draw another line like, I don't know, this one right here. Okay, so of course you'd be given the equations for these two lines, and hopefully you can draw them straighter than I can, but in any case, the point of intersection where these two lines come together is this, that's the solution, okay? Whatever that ordered pair is, I know this one, if I'd drawn it better, was supposed to be a 3-6, but whatever. All right, so why is this the solution? It's because it's on both lines. Okay, so think about this. If you had a point that was just on the purple line, like maybe it's y-intercept right here, okay? Well, it would make the purple equation true, whatever the equation is that this purple line came from, it would make it true, but see how it's not actually on the red line? That would make it false. Okay, or if you had a point just somewhere out there like here, negative 9,5, that one's not on either, so it would make both of them false. The solution needs to make both of the equations true, which means on the graph it needs to be on both of the lines. So the reason why that's important is because of problems like these ones. So we're just trying to determine if the point that's given is the solution to the system. Now, of course, you'd be graphing these, but we can figure these out on our own, and yeah, sometimes it's necessary for you to actually find your own values and test them into the equations. So on number 1, right? Let's go ahead and take that equation. I'll start with the first one, okay? So we got, they gave us an x and a y value. That's important. But then they gave us this equation, x minus y. It needs to equal 3, right? But then they gave us an x value that's 4. So I replaced the letter x with 4, and then they gave us the y value that's 1. And then all we're doing here is checking for truthfulness, okay? So you can put a question mark over the equal sign. But yeah, we know 4 minus 1 is 3, and 3 actually does equal 3. That's true. All right, now, since that one's true, that's good. That means that at least this ordered pair is on the line if you were to graph it for that first equation. But we need to check for the second one. So that's 2x minus 3y equals 5. So once again, we go in and replace the two letters, x and y, with their corresponding values. The x is 4, and then the y value is 1. And then we're just checking to see if this is true. Okay, so 2 times 4 is 8. 3 times 1 is 3. 8 minus 3 equals 5. Yeah, it does. So that also is a true statement. And since both of these were true, and we're determining if this ordered pair 4, 1 is the solution, yeah, you can say yes. You can just say true if you'd like. But again, it's true because it lies on both. It's on both of the lines if you were to put this on a graph. So, if by chance the first one was false, I wouldn't even need, if this first one is false, I wouldn't even need to check this one because it can't be a solution to the system because it needs to make both of the equations a true statement. So let's go ahead and do the same thing on number 2 here. Again, I'll start with the first equation, 3x minus y equals negative 12. And once again, they give us an x and a y value here, so I'll go into the equation. The x value is negative 3, so replace the x letter with the number negative 3, and then the y value here is 3. So, checking for truthfulness, I got 3 times negative 3, which is negative 9, and then still minus the 3 there. And this needs to equal negative 12, right? Well, as it turns out, negative 9 minus 3 is actually negative 12. So at least the first equation is true for now. But since it is true, if it was false, I'd be done and I would say negative 3, 3 is definitely not the solution to this system. But it's true for one, so that means I need to check the second one, okay? So let's go in, and once again, we have the equation. Let's go and rewrite it, x minus y. This needs to equal 0, but they've given us an x value that's negative 3, and its corresponding y value is positive 3. So one of the mistakes we see on a problem like this one is, especially if students do it in their head, because they see 3 minus 3 and it's 0, but this is negative 3 minus 3, which is actually negative 6. Well, negative 6 does not actually equal 0. That's a false statement, right? Because we were checking for truthfulness, so there's my question mark. So this means that the ordered pair negative 3, 3 is not actually on the line that would represent this x minus y business. Okay, so if you were to put this on a graph, and I'll just kind of make it my own just so we can see about what it would look like. There's my y-axis. There's my x-axis. The first equation, 3x minus y equals negative 12. Let's see, that would be, that'd be something like this right here. And the second equation, x minus y equals 0. Let's see, it'd be something like this one right here. And again, that means that the ordered pair, -3, I must have drawn that poorly. First line. Let me try that again. So -3, 3, and 12. Oh, yeah, so it actually looks something like this right here. And then the second one still looks the same though. Okay, but -3, 3 looks like it'd be somewhere in this area. So you see how it's on the purple line but not on the blue one? So that's why it makes it true for the first equation but not the second one. And again, that's why it's not a solution. The solution would be, if I did this right anyways, somewhere down here. Well, let's go ahead and get started with this graphing business right here. And, well, both these equations are in standard form. So it's going to go along like the belt work. We got to change these into slope-intercept form. And I'm going to kind of focus on colors this time so we can tell which line is which. This first equation I'm going to do in red. And like I said, with the belt work, I'm going to take it and I'm going to change it into slope-intercept form first. Okay, so that's x minus y. It needs to equal 2. Okay, so solving this for y, I would subtract x's from both sides like this. And if, again, I'd like to see those coefficients 1s. So 1x minus 1x is 0. I'm going to drop this as -1y, and you can see that 1 there. If you prefer it to not be a phantom 1. And then I'll put my x term first, -1x, and then we got a positive 2 there. Okay, finally, just divide all the terms by the coefficient of y to make that coefficient of y phantom 1. Y equals -1 divided by -1 is 1x. And then 2 divided by -1 is -2. Okay, so from this information, we now have the y-intercept, which is what we need. And again, it's not just -2, it's 0, -2, the ordered pair. But we also have the slope. Now the slope is showing us 1. We need to see it as a fraction so that we can tell its rise and run. The 1 is positive. So that means I'm going to have to go up 1 for my rise, and then the run is positive 2, so I'm going to have to go to the right one. From the ordered pair, we have 0, -2, which is right here. Okay. So I'll go up 1 to the right one. Boom, there's the next point. Looks like we can fit quite a few on here. That's all right. Up 1 to the right one, and we just continue this process. So I'm using the stair-step pattern on this, and I'll continue to the left as well, just left 1, down 1 though now. And I'm purposely putting all the points on here because when we work with systems of equations, it may be useful to see all the points. That way it gives us a higher chance to see where that intersection will be. Now I'm also not going to make the line right now because I want to see these ordered pairs. I'll make the line later. Let's focus on the second equation though, which is this x plus 3y equals 6. Okay, so I'm going to take that equation, x plus 3y equals 6, and I'm going to change it into slope-intercept form, just like we're used to. So I'm going to have to subtract the x from both sides first. That's going to zero out the x's, and yeah, we can see the 1's there, drop my 3y, which now equals -1x plus 6, and then divide all the terms by 3. So here we get y equals, I'm going to show it as -1/3 x, and then 6 divided by 3 is 2. So once again, we now have our y-intercept. And not just 2, but 0, 2. And the slope, it's like we saw in the bell work, I'm going to assign the negative to the numerator there. -1/3. Well, why do we want that? Because it tells me my rise is now going to be down 1. The run to the right 3. Okay, down 1 to the right 3. From that ordered pair, which is our y-intercept at 0, 2. So down 1 to the right 3, and we can see the point of intersection already, but I'm going to put the other points on just to be thorough here. Down 1 to the right 3. Okay, and I'll do it in the other direction, left 3, up 1 though, because it's the same stair step. And here we go. So these are the ordered pairs for both lines. And now that we can see both of those, let's go ahead and graph the lines. So here's the purple one, and here's the red one. This will make it look a little bit better. Okay, but the main idea here is that we see the point of intersection is right here, okay? And that right there is the solution. Well, what is that ordered pair? Well, I know that point's kind of big now, but it's at 3, 1. This is the final answer. That's what you're gonna have to put into the assignment. You have to use the parentheses as well because it does want it shown as an ordered pair. And you can see that 3, 1, 3 minus 1 equals 2, that would be a true statement for the first equation. And then 3 plus 3 times 1, 3 plus 3 is 6. Yeah, it makes the second equation true. It has to make both equations true, not just one. This one, same thing. We got the first equation right here. And while it's not showing what's added to the negative 3x, you can show it as plus 0 if you need it. Okay, some of you, I think you understand that the y-intercept there is at the origin. If you understand that, that's great. But if not, then you may want to see that plus 0. So the y-intercept for this equation, it's right at 0, 0, which is the origin. Not that I think anyone cares. But the slope, the slope here is shown as negative 3. I'm going to show it as negative 3 over 1 because it tells me my rise is down 3 because of the negative. And then to the right 1, that's my run. All right, so I can put this on the graph starting at the origin, 0, 0, right here. And then I'm going to go down 3 to the right 1. So down 3 to the right 1 gives me my next ordered pair. And I'll just continue this pattern, stair-step pattern, until I get to the end of the graph. Okay, now I'll do it to the left as well. Left 1 up 3, left 1 up 3, left 1 up 3. Okay. So again, I'm not going to connect the points here to make a line yet. I will, just not yet. Because I want to see those ordered pairs so I can compare them to the second equation, 6x plus 2y equals 12. So let's go and work with this one by changing it into slope-intercept form. So I'm going to work with it directly. We're going to say, let's go and take that 6x, just subtract it from both sides. Okay, so that zeroes out the 6x's, but I can drop my 2y, which is positive because the plus sign equals negative 6x and positive 12. Just divide all the terms by 2. And we see here that y equals negative 6 divided by 2 is negative 3 x's, and then 12 divided by 2 is positive 6. Okay, and that's all the information we need to graph because it gives us, just the equation itself gives us the y-intercept, not just at 6, but 0, 6, the ordered pair, and then the slope is showing at negative 3. So I'll show it as a rise over run, so negative 3 over 1, that's down 3 because it's negative, and then to the right 1. Okay, so let's go ahead and put this on the graph, and I think some of you guys noticed something about that equation, but I'm going to come back to that. So let's put the y-intercept on the graph, 0, 6 right here. And then from there, I'm going to go down 3 to the right 1, down 3 to the right 1. And I'll just continue that pattern until I get to the end of the graph. And I'll go to the left as well, left 1 up 3. Okay. Now we see from the points that we've graphed that these two lines don't have any points of intersection. So let's see what they would look like if we were to put them on the actual graph. See if it'll let me do this. Something like this. That's my purple one, and then the red one. Yeah, I wish I could do that better, but that's good enough. So we got the purple line, and then we got the red line. And I think what some of you guys notice about these two lines is that they're parallel, right? Well, how do we know that they're parallel? And what does it mean if they're parallel? Well, if they're parallel, that means that there is no intersection. And if there's no intersection, that means also that there's no solutions, at least to this system. Okay? So that's what parallel lines will tell us, if they actually are parallel. But what makes them parallel? Well, we got to go back to both the equations after we change them into slope-intercept form. See the red equation that gave us this slope of -3/1. That's down 3 to the right 1. And then the purple equation gave us this slope right here, which is -3/1, down 3 to the right 1. It's the same exact slope. Remember, slope describes the steepness, and if the steepness is the same, the lines are going to be parallel. Now, if we see like this, that they are parallel, we know that there's no solutions. But there's another situation, and this includes us to look at the y-intercept. See, this y-intercept it's at the origin. This other one is at 0, 6. There are different y-intercepts, which is why this one has no solutions. So we'll see an example like this, but think about what that would do if your y-intercepts were exactly the same. What would that do? Well, we'll see that example when we get to it. But for now, this is good. As long as you understand when slopes are the same, you'll have either no solutions or what will end up being infinite solutions. We'll show that. So when lines have the same slope, it's pretty crucial that you understand that you're going to have a unique scenario. You're not going to have an ordered pair just by itself. Now for this problem right here, we can see directly, just right now, that the slopes are not the same. If you ever see that the slopes are not the same, then automatically you have one solution. And there'll be a section on the assignment that will require you to answer just by looking at the equations. It's not going to give you a graph. You have to look at the equations and be able to tell if it's going to be infinite solutions, no solutions, or one solution. It's pretty much just multiple choice, okay? But you can tell pretty quick. Look at this one. The slopes are not the same, automatically one solution. So we're going to go and graph this and actually find it, okay? So the first one, again, I'll do this one in red. Y equals -2x minus 1. And yeah, they gave us the y-intercept. Very kind of them. So we don't actually have to work with this one to change it. 0, -1. And then the slope here is showing at -2. I'm going to show it as -2/1. That's down 2 to the right 1. From the ordered pair, that is our y-intercept. So let's go to the graph. Let's put 0, -1 on the graph. And from there, I'm going to go down 2 to the right 1 to find all my other ordered pairs. Down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And I'll copy it to the left as well so I can see all the points on the graph. Left 1 up 2, left 1 up 2. Okay, and again, I'm not going to connect the points because I want to see what's going to happen with that second equation first. This one. And yeah, they already told us what the slope and the y-intercept were. Let's start with the y-intercept. It's not just 2, it's 0, 2. Okay, and then our slope, I'll assign the negative to the numerator, so it's -1/2. That's down 1. And then to the right 2. Okay, from that ordered pair 0, 2. So let's go and put that one on the graph. 0, 2. So down 1 to the right 2 gives me this ordered pair. And notice that the slopes are different, even though they may seem the same. They are different. So down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. I can fit one more. There it is, all the way to the end. But I'll do the other direction as well. Left 2, up 1, left 2, up 1. And we already see that point of intersection. But let's finish that line first. All right, so we can see both lines. Let's go and put them on the graph now that we know where that intersection is. There's the red. There's the purple. There we go. All right, so we can see that point of intersection. It's right here. Well, that's where our solution is. And that solution is at, looks like it's at negative 2, 3. Okay, that's the actual answer that we want on this. Let's start by just, this first one, I'll do it in red again. So let's write it up above so we can work with it. Negative 2x plus y equals 1. Okay, so I'm going to change this in a slope-intercept form, add 2x's to both sides. And actually, that's all we need to do for this one because the y is just already by itself. So it's y equals 2x, positive 2x, and then a positive 1, so plus 1. So right here, just from this, it's already in slope-intercept form, so we can see our y-intercept, which is at 0, 1. And the slope is showing as 2. So I'm going to make it 2 over 1. 2 is positive, that's my rise, so it's going to go up 2, and then the run is positive 2, so it's going to go to the right 1. Up 2 to the right 1 from the ordered pair, 0, 1. Let's get that on there. And then from there, up 2 to the right 1. Up 2 to the right 1. And I'll do it backwards as well, left 1, down 2. That's about as much as I can fit on for the red line. Okay, so again, I'm not going to connect the points because I want to see what's going to happen with the purple equation too. Okay, so let's go and put that one on here. Four x minus 2y equals negative 2. Okay, so principle of equality here, I'm going to zero out the 4x's, so I got to subtract 4x's from both sides. I can drop my negative 2y, which now equals negative 4x and a negative 2, so minus 2. Divide all the terms by the coefficient of y, which is negative 2. And now it's changed in the slope-intercept form. Y equals negative 4 divided by negative 2 is 2, 2x. And negative 2 divided by negative 2 is positive 1. All right, now, again, I think some of you guys noticed something about this purple equation compared to the red one. But I'm going to continue as though we didn't notice that because this is pretty new to us, and so you may not have noticed that right away. My y-intercept here is 0, 1. And the slope is not just 2, but I'll show 2 over 1. That's up 2 because it's positive. Then my run is positive, so it's to the right 1. Okay? Well, let's go ahead and put this one on the graph, see what happens. So you can put that ordered pair 0, 1 on the graph. You go up 2 to the right 1, and you see what's happening is we're just directly on that red line. And so there's actually many different points of intersection on this. And so when I put this on the graph, I really only got to put one line on the graph, right? There you go. That blue line represents the graph, not just for one line, but for both. And why does that happen? It's because if you go back over here, notice that, and this, when the slopes are the same, you automatically get some kind of unique scenario, okay? But what also happened was that the y-intercepts were also the same. And if you go back even further than that, just like I pointed out, notice that the equations were exactly the same once we changed them into slope-intercept form. So, in problems like this, when the equations are in slope-intercept form, and are exactly the same, then there are infinite solutions, okay? And that's what we have in this situation. We don't have just one point of intersection. They're the same line, so they intersect everywhere. There's an infinite number of solutions. Of course, we're not going to make you show them all, especially the decimal ones, because that would suck. But we can just write out that there's infinite solutions on this one. So that's the answer for us on this one, infinite solutions. Okay, so if you ever see this, where you've changed both equations in a slope-intercept form, you get the same equation, automatically infinite solutions. Okay, but again, if you do this, if you didn't notice that, you may have to use some graphing. In the section of the assignment, it's not going to give you a graph to do that, so you may have to do it by hand. But what we want you to do is notice that the slopes are the same and the y-intercepts are the same. Whereas that last problem that had no solutions, which is the opposite of infinite solutions here, if it has no solutions, the slopes were the same, but the y-intercepts were different. Okay, and we can see that pretty quick as long as you understand where they exist in slope-intercept form. So for this one, y equals -5. That'll be our first equation. And yeah, I'll do it again in red. And I don't really need anything else from this equation in order to graph it. It is in slope-intercept form. Some of you guys like to see that as y equals 0x minus 5. But as long as you remember, this is just a horizontal line. Where y equals -5. And what I mean by that is that all we're doing is identifying where -5 is on the y number line here. And then just making a horizontal line. It's a flat line. Okay. And yeah, I did that by hand, so it's not so flat, but it works. Okay, so that's my first equation, and it wasn't too bad. Remember that the slope being 0, that gives you a flat line. I don't know how many of you guys look at it like this though. So if you know that y equals -5 is just a flat line, that's good too, because we've seen that before. We've seen it quite often. So let's go and do the second one. And this one's already in slope-intercept form. It's very nice, very convenient. So let's go and identify the two pieces of information we need, the y-intercept and the slope. The y-intercept here is -9, but make sure you put that as an ordered pair. And then yes, they also gave us a slope, which I'll show as -2, but I show it as a slope, as a fraction, so that we can see the rise and the run. The 2 being negative means this goes down 2. And the 1 being positive means this goes to the right 1. Rise over run. Down 2 to the right 1 from the ordered pair, 0, -9. And I think some of you notice we can put 0, -9 on the graph here, but I can't really go down 2 to the right 1 because I'm off the graph. You can, kind of, but I need to go to the left because I can't really fit any other points on the graph. So that's what I'm going to do. So I'm going to change this up. I'm going to go left 1, up 2. Again, I'm just copying that stair step, left 1, up 2. And yeah, we can see that point of intersection right there, but I'm going to continue because graphing is probably more fun for me than it should be, but left 1, up 2. And that's all I can fit on the graph. Well, we can see the point of intersection right here. That's our solution. That appears to be at -2, -5. Yeah, let's get that purple line on the graph. Now, one thing I want to point out too on this one. See how the y value was -5? It says y equals -5. So that means that no matter what we do with the x's, the y's have to be -5. And you see how it's part of the solution. So if you ever see this, y equals -5 like this, you can automatically just put it in the solution. Okay. If by chance we'd gotten something like -6 on this, then we just know we did something wrong, usually with the graph. But once you see, even if it was like x equals 3, then you'd know your x value is 3. See what I'm saying? Right there, there's our objective. I know a solution to a system of equations is the point of intersection between two lines. But we also saw if there's not a point of intersection, that it's possible that there's no solutions to a system. Or if they end up being the same equation, then there's infinite solutions. That'll be crucial because not only are we going to see that on the assignment, but the mastery quiz, which is next time on this lesson, it's going to have at least one problem on there that will be either infinite solutions or no solutions, and you have to figure out which one it is. So you guys are going to see on the assignment from time to time as well, you'll see your x and y axis like this, okay? And what you'll see is that like a line is going to look something like this one, and maybe something, yeah, canvas, thank you. Canvas, something like this one, okay? But if you see something like this, it doesn't mean that there's no solutions, because if you were to continue the red line over here and the purple line, I mean, if I'd drawn them better, then you would see that there's going to be an intersection over here. Now, you're welcome to follow those lines over until they connect. Other than that, what I would recommend doing is just kind of getting the problem wrong until it gives you a new one that will connect, okay? We shouldn't see anything like this on the, I guess, on the master quiz. I could be wrong on that. But yeah, it's possible you may have to extend either the graph your own on your own. But just understand that there still is a solution, because the slopes are different for these. And so you may have to extend your graph a little bit to see what that is. Here's our next system right here. Yeah, so I switched up this number a little bit here, right? It's 14, so change that on your notes. I got y equals negative 3x as the first equation. And that one's already in slope-intercept form. That's pretty good. So that means that we can graph it right now. All right, and again, I'll do this one in red. And for those of you that need it, if it helps, we can also look at this as negative 3x plus 0. This helps us to see what that y-intercept is. So that y-intercept, we can see the y value is 0. But for all y-intercepts, the x value is 0 as well. So that's right at the origin. And the slope, the coefficient of x, it's just showing as negative 3 right now. But again, for me, I like to see it as a fraction, so that I can see the rise and the run. So the 3 is negative, which means we'll go down 3. And the 1 is positive, so we'll go to the right one. Rise over run. From the origin, so the origin right here. And we'll go down 3 to the right one. Down 3 to the right one. Down 3 to the right one. Boom. Okay, and I can actually copy that the other direction. Left 1 up 3. Left 1 up 3, just like we've seen before. And again, I'm not going to connect my lines right now because I want to see what the other line will do. So let's go and do that one. Again, I'll do it in purple. But I need to manipulate this so that it's solved for y. Y equals mx plus b. So I'm going to have to subtract the 6x from both sides. And I'll just remind you, I'm offsetting this minus 6x because it's not a like term with the 14 that I can combine the two. So what am I left with? That'll zero out right there. I'll drop my 2y, which now equals negative 6x, and then positive 14. And I'll divide all the terms by 2 to make this y equals 6 divided by 2 is negative 3, negative 3x, and then 14 divided by 2 is 7. All right. So we now have our y-intercept at 0, 7 with the slope. That's negative 3, but again, here's another fraction, right? Negative 3 over 1, that's down 3. That's my rise, and then the run is to the right one. From that ordered pair, 0, 7. So let's go and put that on the graph. 0, 7 right here, down 3 to the right one, here, down 3 to the right one. And again, I'm going to continue that throughout the graph. That's all I can fit to the right, but I can go to the left 1 up 3. Now this one, I think it'll be better if we can see the two lines on this. So let's go and put that on there. There's the red one. And here's the purple one. Now, like I was talking about at the end of that last problem, is we can see that these two lines, they're parallel. And does parallel have two R's? I don't know, but I also don't care. So since the two lines are parallel, this one just has no solutions, because the two lines will never actually intersect. And the intersection of two lines, that's the solution to a system like this. Okay, well, what made these two parallel? That's a good question, because we can figure that out if we go back to the two problems. And I think some of you noticed this. Some of you saw that this slope and this slope, they're the same. And remember, slope identifies the steepness of the line. So if the steepness of the lines are both the same, then you either have the same line where maybe the purple one would have been graphed right on top of the on the red one, or you get parallel lines like this, okay, because the slopes are the same. So you want to keep that in mind, because I believe on the assignment, it gives you problems that do not identify the graph. It just gives you two equations, and as long as you know that when you get parallel lines, you have the same slope, then you get parallel lines right there. So on the assignment, it'll say something like one solution, no solutions, infinite solutions, and you just choose the one that would be appropriate for that particular problem. Now, the other thing you want to notice on this one is not only are the slopes the same, but the other part of this is that the y-intercepts are different. See that? These two y-intercepts are different. And that's another indicator that these have no solutions. If the y-intercept was the same for both, then you just have the same line. That's all that means, okay? But once you see the same slope, it has to either be no solution or infinite solutions. And we'll see a problem that has infinite solutions, so you can identify that too.